Hello, my name is Amani Skandar and today I will be showing you how to create a regression plot from scratch as well as how to generate a formula to calculate the y value and the uncertainty of y. So to start off, we will be answering this question on the right, and it says to first create x and y data in column A and B so to form a linear plot. So let's label our cells A and B as X, and this is as Y. And for our X values, we could just put any numerical order numbers, such as I will put 1, 2, 3, 4, 5, and 6. And for our Y values, we want to put numbers that are closer to each other. So let's say we want to choose values that are closer to 2. So you could put 2.1 and you want to multiply it by the x value. And let's say for our second one, we could put 1.85 and multiply it by the x value. So for the rest of the column, I will be putting values that are closer to the value of 2, and I will be multiplying it by the x values. Now to make sure it's a linear plot, you can always check the graph before you move on. So let's graph this. Go to insert, scatter. Let's try again. Now you could see it is a linear plot. It doesn't have to be a straight line, but it's closer to a linear plot. So now we can move on to our next step. And our next step, let's delete this because we're not going to use it. Our next step, it says to create a regression output beginning in cell C1, so over here. So to create a regression output, you go to data and data analysis, and you'll see regression and click on OK. And we want to select our Y range. And it's always going to be at the 95% confidence level. And for our output range, that's where we want it to be, and we want it in cell C1. And there we have our summary output. For this is the y-intercept plus its uncertainty, as well as the slope plus its uncertainty. So I want to highlight it because we will be using it later on. Our next step is to enter formulas in cell M2 and N2, such that whenever you enter an unknown y value in cell L2, it calculates the corresponding x value in M2 and N2. So by doing this, so let's label our cells. L2 will be our unknown y, and we could just make any random numbers such as 3. And for K3, we will label this as uncertainty. And we could also make up any values for this because it will be calculated later on. Now for our M, let's move that down. M will be our corresponding X. y will be our uncertainty for x. Now we will be calculating the corresponding x and the uncertainty of x. By first calculating the corresponding of x, we will use the y equals mx plus b. So therefore x is equal to y minus b over m. Now we put this value over here. So our y is 3 for this moment, and then minus b is -1, and divided by our slope. And now we want to generate a formula for uncertainty of x, and by doing this we will set a formula for calculating the uncertainty. So there's going to be uncertainty for every value of this formula we created. So as you see, I used this formula, and for every value I added an uncertainty to it. And our goal is to find the uncertainty for x. So by doing this, we need to find the absolute variance. And when you're finding the absolute variance, you always think it's addition and subtraction. And for addition and subtraction, the absolute uncertainties are always additive. So you find So as you see, to find the absolute variance of the numerator, you subtract y minus b, and these uncertainties, which is a and c, will be additive. So it will be c squared plus a squared, and they're all under square root. And we keep the denominator the same for now. Our next step is to find the absolute uncertainty of the multiplication and division of the whole set of equations. So remember, when it's multiplication and division, you always think relative uncertainty. And also the relative uncertainties are additive. So let's write that down. And this would look something like this. So as you see, I divided the y minus b, it's over m plus 1. And for these uncertainties, I just made up random letters. And for the numerator, I also divided it by m plus 1, plus or minus 1. Our next step is to find the relative uncertainty of x. So let's write that down. And by doing this, to find the relative uncertainty of x, you're going to divide uncertainty by the value. So it will be, you will divide this value by y, and the uncertainty of a will be divided by b, and it will be something like this. So as you see, I divided the uncertainty of c by y and the uncertainty of a by b, and then it's all going to be square root, because that's how it is when you find the relative uncertainty. And all of this is going to be squared over under the square root. So this will cancel out. The squared and the square root will cancel out, leaving it as it. So now our squared and square root are canceled out, and now we could use the formula we generated it, and we plug it into the uncertainty of x to calculate the uncertainty of x. And we will do this by plugging in the values highlighted from the table, and we create an uncertainty of x. So let's start. So equal to, our x value is this one, and then the square root, And if you can't see, I'm using exactly this equation and plugging it in for the uncertainty of x. So our C is the uncertainty of y, and that's the number we created earlier. So you click on this one, squared. Then our A value is the uncertainty of B, and we get this from the table. Then divided by our Y value, which we created earlier also. Minus our B value, which is from the table. And let's put parentheses around this. And then our left values is the n over m. So we put plus, and n is going to be the uncertainty of our slope. So it's this one. Divided by the value of the slope, which is this one. And now we made a formula to calculate the uncertainty of x. And we also made a formula to calculate the corresponding value for x. So let's say if we want to change the value of y, it will automatically change the value of x. And the same thing if you want to change the uncertainty for y, it will automatically change the uncertainty for x. I understand that this can be difficult to create when you want to create a formula for the uncertainty of x, but make sure you follow one step at a time and you will understand it and it will make sense. I hope you understood the video, and I hope you can now formulate formulas for uncertainty of x and the corresponding x. Thank you for watching.